Hello everyone, welcome to the third and final video for semester test review, and this will go over 6 weeks 3. Remember that we skipped from 19 to 22 in 6 weeks 2, so we're going to go back and do 20 and 21 here to start off 6 weeks 3. So we're being asked to factor. Let's go ahead and draw an X puzzle. Remember that we need A times C at the top and B at the bottom, where A is 1, B is 4, C is also 4. A times C is 4, and B is 4. So we are looking for factors of 4 that also add to B4. If you need to do a T-chart, go ahead and do it. Your factors of 4 are 1 and 4, 2 and 2, and I recognize that 2 and 2 are my factors without doing a T-chart, but you could go ahead and do one if you needed to. So 4 is 1 and 4, and 2 and 2, everything was positive. Then if you draw your X box, you will have X squared and 4, and then we can fill in our 2 and 2. So 2x and 2x. My GCF across is an x. My GCF across the next row is a 2. Same thing on the columns. I have an x for the first column and a 2 for the second column. So I have x plus 2 and x plus 2. And that's my final answer. The second one, the first thing that I notice is that we can take out a greatest common factor because 9 goes into 225. So we can pull that 9 out to the front and say what we have left. Remember, that's like dividing everything by 9. So if we divide 9 by 9, we get 1, and so we're left with x squared. 225 divided by 9 is 25. And so what we're left with in parentheses is one of our special factoring options, which is difference of squares, because x squared is a perfect square and so is 25. It's the perfect square of 5. So we can use this formula over to the right to just immediately step to writing our factored form. We take the square root of each term. So the square root of x squared is x. We write that in the front. The square root of 25 is 5. We write that in the back of each parentheses. Notice that one needs a minus and one needs a plus. Does not matter which order you write the plus one or the minus one in. Please don't forget to put your greatest common factor, our GCF, carries over to here. All right, let's go ahead and jump down to 23. We want to solve now. Problem number 23, you may have a different version of this review and your equation may look a little different. Scratch that out and just put this equation and work this equation. All right. So the first thing I notice is that we are not in standard form. We need to be in the form of ax squared plus bx plus c is equal to 0 if we're going to solve. Normally it's equal to y, but we set it equal to 0 in order to solve because we want y to equal 0. So I need to add 9 to both sides to get standard form. So then we'll have x squared minus 6x minus 9, or sorry, plus 9. I don't know why I wrote minus there. Make sure you put if you add to one side, you add to the other. And then we equal 0. So again, we can identify our a, b, and c. Remember that there's a 1 in front of that x, and that's our a, this is our b, this is our c. Now this one could be done by factoring to solve, but since I already showed you a couple of factoring problems, I want to go ahead and do this one with quadratic formula. So reminder of what the quadratic formula is. It's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in a, b, and c. So x is equal to negative b, but b is negative 6. Be sure you put that in parentheses. You have a double negative here. There's one in the equation and one in your b term. Plus or minus the square root of b squared. Parentheses are again important. When you put this into your calculator, you must put the negative 6 in parentheses. Minus 4ac, 4 times 1 times 9. And that whole thing is all over 2a, which is 2 times 1. Simplifying, I'm going to get rid of parentheses first. Negative 6 is positive. Under my square root, I'm going to have negative 6 squared is 36, and negative 4 times 1 times 9 is negative 36. Positive 36 minus 36. That actually gives me square root of 0. And then all over 2. What is the square root of 0? 0. So this reduces to 6 over 2, or 3. So x is equal to 3. Notice that the stuff under the square root, our determinant, was 0, so we knew right then that we were only going to have one real solution. All right, number 24 is kind of unique. It could be solved with any of the 5 methods that we've learned this 6 weeks. I'm going to show you 2 of them. I'm going to show you difference of squares one more time, but then I'm also going to show you square roots. A reminder over here in the corner, if you're going to use square roots to solve, you must have only something squared on the left and a number on the right. So let's do this by difference of squares first. I think this is probably the easiest way because x squared is a perfect square, 49 is a perfect square. So remember to do that. First I'm going to change my color here so that it stands out. We do our 2 sets of parentheses equal to 0. We put the square root of the first term in the first one. So the square root of x squared is x. Square root of 49 is 7. One gets a minus, one gets a plus. Here we need to set each expression equal to 0. X minus 7 equals 0. X plus 7 equals 0. When you move the 7's around, adding 7 here, we get x equals 7. When we subtract 7 on this one, we get x equals negative 7. So there's one way to do it. Here's number 2. So we're starting with x squared minus 49 equals 0. We need x squared by itself because we can only have something squared on the left. So we need to move 49 over. So we have x squared is equal to 49. Once we do that, we have the setup that we need. We're ready to take square roots. Remember that a squared and a square root cancel, leaving me with x on this side. The square root of 49 happens to be a perfect square. It's the perfect square of 7. And don't forget the plus and minus on it. Same answer, 2 different ways. Let's look at problem 25 and 26. These are complex numbers that we are going to simplify. Notice that there is a plus sign here between the 2 complex numbers. That means we are adding. We're just simply combining like terms. You could also have a negative sign that you are subtracting, or if there is nothing in between, no operation, then remember that means multiplying, and you can do that by distribution or box method. But here we are just simply adding, combining like terms. I like to circle my real parts and box my imaginary parts to help me identify like terms. And so I get negative 5 minus negative 8 minus a 1 that's implied there gives me a minus 9i. And that's my final answer. Remember that the real part goes first, followed by the imaginary. All right, this next one, we're going to need to simplify some square roots and then combine like terms. So the first thing I notice is that a couple of these have a negative sign under the square root. Remember, we pop out an I. So we could rewrite this as I square root of 16 plus I square root of 64 minus. Notice that I didn't pop an I out on this one. That negative sign or that minus is on the outside. So it's just a plain old minus sign. What's the square root of 4? 2. All right, so now let's do these square roots. The square root of 16 is 4, and the square root of 64 is 8. So I have 4a plus 8i, and then still that minus 2. I'm going to combine like terms. I have just a single real number and 2 imaginary parts. Remember that complex numbers have the real part first, so negative 2 comes first, and then plus 12i, and that's our final answer. All right, Number 27 asks us to graph the inequality and to make sure in shade. Remember, inequalities have shading. This is a quadratic inequality. We can do this one of a couple ways. One is that we can plug in values for x and see what y is and get some points. We also know that our y-intercept immediately is at 2. This is my y-intercept because this is in standard form. So I can go ahead and put 1 point on my graph. Let's go ahead and use Desmos for this. We can use Desmos to pick some points and plot it that way instead of having to plug this all into our calculator or use our brains just, too much. So let's go ahead and put this in. Let's say y is less than or equal to x squared. Okay, so immediately we're starting to get shading here. This is just my parent function though. I still need to fix it. So 3x plus 2. All right, so couple things to note. One, this is solid because we have a less than or equal to. All right, the other thing to note is because we have a less than, that means that we are shading from the vertex going down. So that's why the shading is outside, because we're going down below the vertex. I have my point that I already identified, 1, 2. This one's in kind of a funny place. It's at negative 1.5 and negative 0.25. We're just going to have to do the best we can to plot that on our graph. And then a couple more points, I can pick out the x-intercepts, and that'll give me plenty of points because I can reflect that point over. So there's all of my points. So I'm going to go back over to my graph and graph these points. I already have the 0, 2. I'm going to pick up the negative 1, 0, negative 2, 0, and negative 1.5, negative 0.25. And don't forget to shade. Negative 1.5, negative 0.25. There's our vertex. And then we also have points at our intercepts here. We're getting a lot of points kind of crammed in there. All right. I think I want to pick up one more point because all these points are really super close to each other. I want something maybe at, let's see what it is at 1 or 2. Let's take a look back on Desmos again because I'm just not feeling super confident in being able to graph that. So if we go over here, we can see that there's an intersection at 1, 6. I keep almost landing on it. There it is, 1 and 6. So let's graph that point as just another point a little further up on our graph. So I'm going to go to 1 and 6. And remember, I can mirror that on the opposite side here. Now I feel a little better drawing my graph. Remember, I'm either looking at our inequality symbol here and seeing that we need to go below less than is lower, then I can show my shading on the outside of the parabola. And we're done with that one. All right, next one, we want to solve a quadratic inequality. This was our very last lesson of the 6 weeks, so hopefully it's fresh in your mind. All right, so the first thing I see is that I have a 4 on the wrong side and I need to move it because we need standard form in order to be able to solve this one since we have 3 terms. So I'm going to have x squared minus 3x minus 4 is greater than 0. Okay, remember if it's a greater than, it's an or case. We're going to need that later. All right, first step is to rewrite this as an equation. So I'm going to come up here and say x squared minus 3x minus 4 is equal to 0. This looks like a really simple one to solve with an x puzzle. So I'm going to look for factors of negative 4 that add to negative 3. Since I'm adding to a negative number, my bigger factor needs to be negative. Negative 4 and 1 will add to negative 3. So I can write my factored form as x minus 4 and x plus 1 is equal to 0. And I'm ready to solve my 2 expressions equal to 0. So 2 little equations here. When I solve these, moving 4 by adding it, I'm going to get x is equal to 4. And subtracting 1, I'm going to get x is equal to negative 1. Remember, those are not our solutions. Those are just our critical points on a number line. So let's draw that number line and put these critical points in. So I'm going to put -1 here, maybe 0's there, and 4 is over here. So I need a point at -1 and at 4. I need to remember from my smiley faces back on video number 1 that these are open circles because it's a greater than or less than symbol. Because it's an or, I'm going this way, and I'm going that way. I'm going in opposite directions, meaning x is less than -1, or x is greater than 4. It's an either or, not an in between. Problem number 29 is a nonlinear system, and we have a parabola right here. We have a quadratic, and then our data in the table is going to give us a second equation. And notice that these are all going up in increments of 1, and these are all going up in increments of 1. So we definitely have a linear function. So we will create an equation for our line by putting this table into Desmos using the steps from problem number 2 all the way back at the beginning. And then once we have that equation, we can put both equations in Desmos and find the intersections. So let's take a look at Desmos. All right, so my first piece is an equation. Y is equal to x squared minus 4x minus 2. So I just put that in and I get that red parabola. All right, then I'm going to put in my data. Remember, to get a table, you go to plus and select a table and just start entering your data. In fact, Desmos may even start helping you after a while. It's pretty smart about starting to know where things are headed and start filling things in. So we'll get these points that are in purple. You can see very easily that that's a line. We want to put it in and tell Desmos to draw that line as a y equals mx plus b, remembering the funny little notation that we need, that it's y1 and x1 and that approximation symbol. Let's take a look at what that line looks like now. And I just wanted to point out where that approximation symbol is. It's on the ABC keyboard, and it's between B and N down below it. See that little squiggly line? It's an approximation symbol. You can also find that on your Chromebook. If you look right above the tab key, you'll see it, but you have to hit shift to get to it. So shift and then that key right above tab, right below escape. All right? So we have a line and we have a parabola. And so right from here, we can see where our solutions lie. 0, -2, and 5, 3. Remember that solutions to systems are where the graphs cross. So those are our answers. You can also get the equation here, the y equals mx plus b, m is 1 and b is -2. So we'll go ahead and write that while we're at it as well. So our equation from our table is that y is equal to x minus 2, because m is 1 and b is -2. And our solutions are, as I said, 0, -2, and 5, 3. Y is equal to x minus 2. That was the table in the form of an equation. Our solutions, or the places where those two graphs cross, are at 0, -2, and at 5, 3. So we had two solutions because we had two crossings. That becomes important for this next problem. Number 30 is super easy. It's just asking how many solutions are there to this system. Well, I just said it. If we have two places where the graphs cross, we have two solutions. Two solutions here. So two solutions, and we are done with the semester exam review. Good luck, everybody.